developed this panel that we were going to follow Senator Merkley, I would have named it, Can AI Save the Planet? So I'm going to go off script of what we prepared and talk to these guys, but first I want to introduce the panel. I really, if you want to talk about AI in the utility industry, this is the dream panel to have up here. And we had one short conversation, and we're all on a first-name basis, so I'm just going to say their first name. First, we have Marissa. She's the Chief Technology Officer at UtiliData. UtiliData is a company whose product is artificial intelligence, and Marissa develops that for the company. We also have Mahesh. We're going to the opposite spectrum in business. He is the, I gotta get this right, Chief Digital Officer at IBM for Energy, Environment, and Utilities. He's going to give us a global perspective and a cross-industry perspective on artificial intelligence. And we have Ram. He is from one of the largest utilities in the United States. He is the Senior Project oops, that's me. He is the Vice President of Innovation and Technology at American Electric Power. And I want to just start out by, I was going to have them talk about what they're doing with AI in their particular company right now, but I actually just want to jump right to the potential for AI. And I have no particular order here. Actually, let me back that up again, because Steve kicked this off. AI was woven through almost every panel, every speaker that we had up here, but does everybody out there have the same definition of what artificial intelligence is? So let's try this. We'll start with Marissa. What is artificial intelligence? What are we talking about up here today?
So from my company's perspective and my perspective, artificial intelligence is the ability for our devices on the grid to act autonomously and smartly. And that means that they need to have information and communication locally, but it's a decentralized system that allows those devices to respond to local conditions in real time.
Mahesh.
Okay, I will I'll go one step higher so that I try to explain AI in more general terms. AI the objective of AI is to create a system that does four things. That's understand, reason, learn, and interact. And this is the foundation of what we are trying to build towards, right? And to do that, there are foundational words that we always come across, such as machine learning and deep learning. The machine learning and deep learning are basically computational methods to go about and achieve that. And there's always a confusion between machine learning and deep learning. I want to settle it before we start. Deep learning is a subset of machine learning, right? And I will keep it at that level.
So coming last, it's good and bad in that it's hard to beat up my fellow panelists. The definition I use, and anyone who's done any level of computer programming knows, when you write a program, you have to tell it exactly what you want it to do, give it the exact inputs, and you get the results that that algorithm and that input have determined. It's very deterministic. And I look at AI and the whole field, and I think we're right at the beginning of a massive change in the way computing and artificial intelligence can impact our lives. But it's more, the system doesn't really need to know everything at the beginning or have all the inputs at the beginning. It learns. It's able to understand what it's getting. It takes the data that it gets and it keeps making, it's not deterministic, it's more probabilistic. And it can weigh decisions and say, it really acts, and any of you who've had children, it really acts like the way a human child learns things by trial and error and then says, okay, now I know this is a better decision, strengthens the things that make sense and weakens the things that don't make sense.
How important is artificial intelligence to the electric power industry across all of our goals for a greener grid, more efficient operations? Who wants to take that first? Actually, I'm going to go back to Ram. How important is it at AEP to reach your strategic goals as a company?
So being a geek, as you probably guessed.
That's why you're up here.
I honestly believe in the great potential of AI. And I hope all of you or some of you have seen or heard of the Gartner hype cycle. You know, it's got a peak and then it's got a valley. And, you know, they map where different technologies are. And I think AI has a lot of potential, and we're doing a lot of pilots internally. We have 2 domains that we're doing pilots in. One, we're doing a lot more, which is the asset maintenance of our assets, checking asset inspection, asset health, predictive analytics on assets. And the other is interaction with our customer. That's a little smaller, where we try to automate transactions and queries from our customers. And I'd say all the pilots have done pretty well. And like we talked on our preparatory call, we haven't taken any of those pilots, though, even ones that show promise, and scaled them. I think that's because it's not just the technology, it's about the people, the process, and changing the culture internally to say, I trust the system's giving me the right results, and I don't need a human in the loop. So I think we're at the early stages. I think there's great promise. I think sometimes hype's mixed into it. I think the data that you feed the system is critically important, and one utility has a lot of data, but lots of utilities have even more data, and the more you can feed data to the machine, the better the results.
Okay.
Mahesh, are they starting in the right places?
So Ram mentioned a few words which actually get a response from me. So I've been trying to do AI with utilities for the past 9 years. So this is something that we started off in 2011, 2012. That's when the topic started getting some resonance. So I consider AI happening in 3 phases. So the first phase is what I call random acts of AI. So that was phase 1, right? And that went on for a while. And then the second phase was what I call death by 1,000 POCs. That was phase 2. And now we're getting to the third phase, which I call the aha phase, wherein everybody agrees that AI has value, and everybody agrees that AI can be used to do certain things, right? And so in the past probably 18 to 24 months, we have entered this phase, right? And I see a lot of promise coming from this. The second thing, whenever we discuss AI, is immediately the topic of data. So data is important, right? And yesterday there was a panel that spent a lot of time discussing this topic on data. I want to add a practitioner's view on that. See, data is important. There are certain use cases that need a lot of data. Certain use cases actually don't need a lot of data. What is more important is how do you get to the data? And this is very particular for utilities. For utilities, monitoring and diagnostic is not new. So since it's not new, you're already collecting a lot of data. But the challenge is to get to the data to do something. And then that brings me to my next point. Once you do AI is intelligence. AI is like a smart kid, right? If you keep a smart kid on the side, it's of not much value. You have to use the smart kid to do something. So you have to infuse the AI into a workflow in a utility. So when you get these 3 parts, data, how do you get to the data, and once you start infusing AI into a workflow, that is when you start realizing value. And just like Ram mentioned, there are 2 places in a utility where all the 3 things are understood. One is asset maintenance, condition-based maintenance, preventive maintenance, because it's a body of data, approximately know how to get to it, and we know the workflows involved. The second is around customer. The second category wherein I see a lot of progress happening in AI is basically in the sphere of real time, right? Because there's a lot of progress that's been made in the past 3 years from a technology perspective to do deep learning on time series data. And because of that, real time is coming to the forth as an emerging use case.
So I think both of you guys are on the right track, but I'm going to take a slightly different tact on the question of whether or not AI is important for the electric industry. Building on the senator's comments, if we're going to reach a decarbonized grid by 2030 or 2040, the pace of change has to accelerate by about 7 to 10 times what we did in 2018. So the amount of renewables we deployed in 2018, utility scale as well as distributed, has to increase by a 7 to 10x fold this year and every year after this in order for us to reach those goals. That's a dramatically different grid that requires a dramatically different operating principle. A lot more little pieces, a lot more flexibility needed, and a lot less centralized operation. I think companies like AEP that have been piloting these technologies, I think it's time for them to now start laying the foundation for that operating principle, which really comes down to, as Mahesh said, it really comes down to the data and the access to that data. And the thing that this industry suffers from is a lack of competition when it comes to that. We have a hard time monetizing that data because we are worried about security and we are worried about protecting our customers. We have to solve those two problems if we want to see competition and innovation in that space of artificial intelligence around taking that data and operating the system differently. And I think it's critical in order for us to reach our decarbonization goals.
Ram, give us a utility perspective on that.
So I do think the concept of data, and Marissa touched on it, and I was actually at a NREL conference with Chairman Thomas where we discussed data, and the regulators also understand the constraints on data and safeguarding privacy and security, but freeing the data to allow it to do things that'll benefit both the customers and the grid. There is no simple answer to solve it. It is clearly an issue. The utility takes cybersecurity, custody and protection of our customers' data and grid data and privacy and security extremely seriously, which in its own way puts a lot of pressure on trying to get access to that data. Especially things that feed our industrial control systems, SCADA, customer usage data. All this data has to be freely available, accessible to drive these. It's work in progress. We are looking for legal frameworks. We're looking at actually, can technology help solve the issue about consent and permissioning? Because right now it's kind of complicated to go to 5.4 million customers and say, do you consent to give this data for this long to this provider? And then when the customer says, I withdraw my consent, how do I do that? And if you do this with spreadsheets and email, it's unmanageable. Can you do this with new technologies that allow for this permissioning? And I always describe data as a three-tiered structure. There's the data governance layer, which all these things come into. And there's lots of legal, contractual, cyber components to it, as opposed to just the data in a database. And then there's a whole technology part of structured and unstructured data. But then there's the platforming of the data, and then the apps on top of that platform. And all three have to work together. So it's a long answer to, yes, they're right. Yes, the utilities realize there's a problem. Yes, we're working on it. Maybe not at Marissa's speed, but we're all working at it.
And just to add to that, right, I'm like, I see in the past probably 18 to 24 months, especially standard, like for example, industry bodies like EPRI and the Edison Electric Institute and all of these guys, they've started taking measures to consolidate data. They have got like standard, especially for data related to vision and computer vision, like for training. They have started on the first steps of creating a repository that like us as a technology vendors could start using. It's early steps, but it's steps in the right direction.
Anonymized data.
Yeah, of course, absolutely. So that frees a lot of people.
Yeah, I was going to say, I think one thing that we should remember is that the operation of the grid gets more efficient with more data and broader perspective. So, interconnect-wide planning, feeder-wide planning is more efficient. But if you have high-resolution data and you can keep that locally, you can make good decisions locally. And so when we talk about a decentralized grid with lots of distributed energy resources and lots of participation by customers in terms of that flexibility, that data doesn't necessarily need to leave the premise even for it to be valuable. And I think that's where I was saying, as we make investments in technology in the next 5 years, we should be making sure we have technology that can support that kind of action. So meters on the side of your house could be essentially a micro PMU in terms of supporting the grid, and it can provide the high enough resolution data to understand what's going on behind the meter. Both of those pieces of information should be secured and protected, and they don't necessarily need to leave premise in order to make good decisions. And so on Mahesh's point, that's that, you take data and you get understanding, you analyze, and then you take action. That action can be done locally and therefore a lot more securely.
So it's a two-part question. One is, as we look out at this audience that we have here, many of them are involved in either developing policy or influencing policy at both the state and the national level. So what are things that you would like them to know, or where can they help this process along for both innovators and utilities?
Do you want to
What is, and maybe I should phrase it, go
yeah.
ahead, Marissa, and I could phrase it differently for Ram from a utilities perspective.
So that's a really big question.
I know.
I think from policy perspective, for a small company making innovative technology, I think there are a couple things we could do. One is make it possible for the utility to make an investment in technology without handcuffing them to a performance that is really an unknown at the beginning of that. So in other words, I think regulators should allow utilities to take on more risk, not reliability of, reliable delivery of energy risk, but risk in terms of the technologies they actually invest in. And then the second thing is I think
Meaning
we need...
that if those technologies fail or it takes
right.
longer, that's part of the process.
There's some forgiveness in that.
Yeah,
and
you
then
learn from failure.
Yeah, and then I think the other thing that we should, take note of over the last 10 years, we have been piloted to death, and we've been piloted to death on very specific, narrow applications of technology. And I can't remember who said it this morning, but actually I think it was Kaufman who said this morning, we really need to start evaluating technologies in systems. Absolutely. And so that's the second part of the policy, is that you can't make a big transition in the energy economy with mandates for really narrow pieces of technology, this much rooftop solar and this much wind energy or this many electric vehicles. We really do need to come out with policies that hit system-wide goals and then allow creativity and innovation and the utility to work together to get there.
I would like to add this, and I would like to add two perspectives to this. And one of them is a personal perspective, and the second is something that I'm feeling as a practitioner. So when we started working with AI, probably circa 2010, it was about advanced analytics, then we went to mobile, then we went to AI, then we went to blockchain, now we're talking quantum, right? This is just the past 8 or 9 years. So one thing is certain, technology is going to change, technology is going to get better. So you can't make choices around technology because technology is going to improve and it's going to change. That's the beauty of technology. One thing that is definitely going to stay constant is the amount of data that is needed to get things done. So from a policy perspective, I would say that how we look at data and data gathering from a platform perspective, that should be the priority, not exactly picking the technology to solve something. The second thing which I heard, which I want to talk about is my recent experience. Like we are trying to do a project in Europe around N-1 simulation. We used AI, like a few AI algorithms, not AI, a few AI algorithms solve that problem in a probabilistic fashion, right? And we actually did a pretty good job. We were able to beat the traditional N-1 system almost every time. But the thing is, everything that's probabilistic has a long tail. So it is not 100%, right? So, and this is something that becomes a challenge to explain when someone is operating the same simulation using an expert system or a rule-based model, which definitely is not 100%, but it is okay from a regulatory standpoint. So how do we start positioning better technology to replace some situations like these? Because the AI could potentially help solve certain challenges in a better way, but regulation does not support it, so it doesn't get adopted. So these are like two, I'm probably not answering the question, but sharing two perspectives.
No, and that's just, Ram, you perked up as soon as he said regulation.
And I was very glad to hear Phil Moeller earlier speak. And I had said this when we had a meeting on Tuesday. I'm in charge of innovation and technology, but all innovation and technology in the utility ends up at the rates department. And both of them are reflecting that in a way. I mean, the way we act is based on the way we're incented. The way we're incented is based on the rate structure. And we usually do pilots somewhat at risk. It's changing, and some states have been excellent. California, particularly New York in certain cases. Illinois, surprisingly very progressive in terms of allowing the utilities to put money at risk, to do pilots, to learn more. Right. So the pilots tend to be, to Marissa's point, much more narrow than, because we think of it as all at risk. But that's only part of the issue. The other part of the issue is this, and I think a really important one, but a little more obscure issue, which is a systems view of these things. And we are guilty as much as any other large organization is. We're bureaucratic and we've got lots of different divisions, and little parts of the division look at little parts of the problem and solution. Absolutely. really usually there isn't somebody who takes these technologies, AI, blockchain, machine learning, they're really horizontal technologies that cut across many, many departments, many, many different areas. And we're not structured like that, so we don't take a systems perspective. We need to we did with the large G, T, and D in years past, but the world is changing and we need to take a horizontal view of technology. And this type of disruption is not unique to the utility business. It's happening in the financial services business, it's happening in the transportation business and in the retail business, as all of you well know.
So we heard Senator Markley say that this change is urgent. Marissa, you second that with more information. You said it as well, Mahesh. Is the utility industry capable of changing that quickly to adapt to our new business and environmental environment?
I could go. I'm like, I absolutely think so, right? But the thing is, this gets me to one of the topics when I'm talking to my clients is, there are problems that you can solve over multi-years. There are problems that you can solve today, and there's some problems that can be solved in an intermediate timeline. So it is all about picking the problems that you want to solve, and as a utility, the utility has to define that value, right? So at the end of the day, solving problems is a function of capturing a particular value pool. There are certain things that technology can solve today. Do you want to focus on those? But then it has to be the utility leadership that defines that value, right? So absolutely.
Marissa?
I think the utility is capable of it, and I think if they don't, it's going to happen without them.
Evolving, are you changing the culture? Is the culture changing at utilities to be able to evolve and adapt faster?
I would say we realize so this is going to be a little bit a longer answer, but we do, I think from our board, our CEO and down, we understand the urgency of the imperative. I don't think there is a lack of understanding at the board level, at Nick's level, our CEO's level and below. And we understand it's not just about technology, it's about culture, change management, and communication. Absolutely. And and 10 years ago, I used to run our technology center at AEP, and we would be vetting vendors' products, and we would say, well, you said that it does this, but it really doesn't do this. And really now, most technology really works pretty well out of the box, whether it's software, whether it's firmware, whether it's hardware, whether it's products or widgets. What's missing is the business model, the case for change, and we in fact, for boiler tube maintenance, we had a startup company that had this robot that climbs up and does the work really well. The people in the organization that sort of championed the pilot all got good results. But changing the culture within the plants has been really, really difficult because they're used to doing it one way. So I think, and I don't want to sound like we're not getting there. We understand the technology, we understand the need to change. Changing a large organization, changing the culture, changing the communication, and managing through that change is an ongoing, evolving thing. But we have support right from the top all the way down that we need to change.
Yeah.
No, go ahead.
So one way I see that, I look at what utilities are doing, and not necessarily what they're talking about. I see that especially in large utilities, the innovation departments are coming up, and innovation departments are getting a lot of strength and funding to do a lot of these initiatives. That means the intent is there is high-level sponsorship, and I'm seeing for the first time in many years that things moving actually pretty quickly, right? So I think utilities are having the right, mission to get this thing addressed. So I'm more hopeful.
So Hawaii Electric's a really interesting case in this. So they had a huge influx of distributed solar that caused them to really rethink how they did distribution planning, but also how they interfaced with their PUC. So they were essentially at a stalemate about 3 or 4 years ago where they couldn't get any more money to actually accommodate that rooftop solar because their PUC and them were at odds. And internally, they had a shift in management and a change in how they approached that decision making that I think is actually a good model for other utilities. It did take a critical event in order to get there, But I think it's possible for both the large utility to change, and I'll say, I think the PUC met them halfway on that.
And, okay, so if certain utilities in our industry are much more ahead of the curve, of the utility curve, let's say, so for those that are not, that are struggling to make those internal cultural changes to the way they run their systems, what's going to happen to those utilities? Are other companies that do know how to use the data going to overtake them in some way?
So I'm a believer that you can't stop technology.
Right.
No matter what, I mean, you might be a laggard or you might be a late adopter, but eventually you're going to get PCs, you're going to get cell phones. I mean, I'm using old technology, but you're going to get AI and you're going to get robotics, and you're going to, it's how fast, and the early adopters, I think, bear a little bit more risk, but will get more reward, will get it more ingrained in their organization. I think we are looking at all technologies, and I think Mahesh said it, there's a vast waterfront of different things that the utility can participate and get involved in. Yeah. Both the vendor and the utility can get POC'd to death, you know? And what do you do with that? Because you only have institutional capability to scale a few of those things. I think picking the right technology, and I'm a big believer again on AI, which hence we're on the panel, but within AI, it's a vast space, picking the right few first use cases and taking them all the way to deployment, I think is really important. We did that with analytics, and we started with a use case on energy theft because it was the easiest, simplest one to show value. I think sometimes we try to make complicated the enemy of good, and you need to take a simple one that's easy to show immediate operational, financial, and resource benefits, roll it out, and then you get more people willing to say, I'll take a chance on that.
And what is some of the low-hanging fruit that utilities should be investing their people and their money in?
I would say the whole asset management, asset inspection, vegetation management, we all spend enormous amounts of what we call operations and maintenance expenditure, which is a pass-through, enormous amounts of that money on that activity, and it's usually time-based, which is the worst way to do it, because you're just doing it whether you need to or not.
Or crisis-based.
Or something blows up, exactly, crisis-based. And what you really need to do is based on the condition and be more predictive, be more proactive, and if you think about the asset basis of any utility, it's large and huge, and you can squeeze out lots of efficiency Absolutely. And lots of financial benefit by using those as your early use cases.
Going back to when I started, right, the use cases that you pick are the ones where you know that you have the data. The second is you know how to get to the data. And third is you know the workflow that is used to do the work, right? So the asset is a good example because it's one of the most important things that a utility does. And everything from a purely technology and algorithms point of view is more or less solved. Now it's an implementation issue, so definitely focus on that. I would also add the second element, which I think a lot of the European utilities are starting to do well, is basically around call center automation, right? Because there's a lot of learning our industry can have from financial service and telecommunication who operate much larger call centers, right? And they have got to a point wherein there's a lot of call deflection as a use case that is done pretty well now. So that is something that can actually be used for utilities. I wouldn't call them low-hanging fruits, but they are in the domain of the solvable, right? And then I think with especially the technologies that I mentioned, working on time series now is a worthwhile effort, yeah.
I actually think the low-hanging fruit is the customer, and I think it fits both the utility and the regulatory body pretty well. I think that there is technology available for customers to ride through an outage, to be resilient in the face of storms, and they can either purchase that technology from an outside vendor or they can purchase it from their utility. And if their utility is offering the ability for a single house, a neighborhood, a feeder to be resilient, that means that technology is also available 24/7 for them to use that for more efficient operations. So I think the hurricanes, the forest fires, those big events are what's going to drive us towards using more artificial intelligence.
So you're not just talking about riding through a momentary outage. You're talking about an extended outage that homes could actually stay energized even if the grid is out around them.
Yeah,
that
so
technology.
we talk about a 4-hour event, 4-day event, forever, right? So microgridding forever, that's a totally different story, but microgridding your house for 4 hours because of an outage or microgridding for 4 days, that technology exists at a low enough cost that customers can start to purchase that. And I think, again, I bring up Hawaii as a case in point where, you know, the cost of the payback time for residential solar dropped to about 2 to 3 years, and it became a no-brainer for customers to put that on their house. Yeah. But they did so essentially in spite of the utility. The utility could turn that around and lead that charge as opposed to have it happen to them. And I think resiliency is going to be that next big play.
One other place I would say is for existing places where you know how to solve stuff, something around outage and outage management, trying to incorporate new data sources. It's a problem understood, you have a method to solve it. Trying to incorporate new sources of data like weather, it has come to a price point where it's very attractive now. So trying to incorporate that is also a way to get to a quick win. And it also is one of your bigger expenses. So
are you talking about like weather data to help predicting renewable performance?
Renewable, I'm talking about something more basic, like for example, incorporating weather as a highly granular input into your outage process. Right now it is done at a very high level. There's a lot of optimization that can be done now. The challenge was handling weather data and computing weather data was computationally expensive. Now with the advances that have happened in the past 5-6 years, it has come to a price point wherein it's attractive, right? And certain utilities of scale should try it.
So Ram, when Marissa talks about almost like a new kind of utility where it's partly on the onus of the customer to have the technology in their home and then they have these other capabilities, is that an asset to the utilities to have that kind of technology, or at the customer side, owned by the customer, right, or is it a threat?
So that goes back again to the all innovation and technology ends at the rate department because the way rates are structured is if it's behind the meter, if the asset is behind the meter and it serves or gives benefits primarily to that customer, it can't be erased and socialized. That's just the way it is. Now, are we trying things with campus resiliency, microgrids as a resiliency concept with a shared infrastructure that the grid gets some benefit, the customer gets some benefit, but it all depends on a rate structure that partitions it. You know, right now, electric reliability is a one-size-fits-all. You pay your bill, you get that reliability. You can't choose a reliability, and you need more. Now, there's a social commentary. Do we want to have a world where people who can pay more can get much higher reliability and people who pay less can get lower? And then the whole resiliency, I know we're working with various government organizations to define metrics. How do you measure resiliency? So I think again, technology is now available to do many of these things. And I think they're willing partners in the ecosystem to deploy them. And I think their pilots will continue. I think utilities will continue to do pilots because they're low dollars at risk. I think to get to what both of them are saying about scaling is going to require policy support and regulatory changes to allow for that. And I don't see any reason why it couldn't happen. I mean, that's why we electrified the United States initially. That's why we have some of the lowest electric rates in the world here. That's why we have reasonably good reliability, and we just have to move on to the utility, like the lady said before, utility 2.0. Mm-hmm. It's time for all of us to do that.
And one thing I would just want to add to what Ram just said, once a technology proves value, and there's an easy way to show value or ROI, I see a lot of utilities adopting it. And I'm talking of our own experience because we as a company started, one of our missions as IBM is to be essential. And when we realized the challenges that utilities were having with vegetation, we went about over 18 months to try to start addressing it in a meaningful way. And then we made some progress. And every time we have been sharing our results back to utilities and working through them, we are getting an increasing amount of reception to discuss it. The problem is not solved. But the thing is, utilities are engaging, and this is something that's probably happening. I'm seeing it the past 3-4 years. So I'm very, very bullish and positive about where this is headed.
So I have a few more questions for them, but I also, if the audience has questions, I want you to be able to, ask your questions of this group as well. Okay, back there.
Last year, here, we heard about AEP's platform where everybody can put power in and take power out. This is going to, I think, result in rates. You're right, it goes right down to the rate department. That we'll have to have something anywhere from one-part rates all the way up to occasional time-dependent rates. But I think moving from rates that recover costs to what we were talking about before, rates that give batteries their true value to the system. And I'm looking at artificial intelligence as possibly understanding what's going on with millions of devices and optimizing, setting price signals. I mean, is that the challenge for AI for the future distribution system?
So one thing, that's an excellent question, and that's the wholesale retail market connection, and how do you expose, and we've been doing pilots, on what we call prices to devices for a long time, and exposing retail customers to wholesale prices, which are right now completely masked. But what if you could have distribution level prices? What if you can have prices to devices where you set it and forget it, and you can set your cost versus convenience? And to do that today, when we tried these pilots, we ran into the computational and data barriers, and those have become, the speed at which computational capabilities, telecom capabilities, and data ingestion capabilities have grown over just the last 10 years have been phenomenal. And I think AI could play a part in it. There aren't many companies actively pitching that, but I do like what you say, and I do think it could play a part of it. And I do think eventually, as we go to a very much more distributed architecture of the grid, much more decentralized, digital, decarbonized, we're going to need prices at many more levels, and we're going to need it to be done automatically without engagement of a human being to constantly interact and be trading power and optimizing for the circumstance that they're in.
Yeah, I'm Heather Curley with Wilson Sonsini, and I think on that data point, Ram, I guess I'd be interested, what are the potentials that seem to be opening up with quantum computing and AI here in the electric industry?
So I did a presentation to our executive council on blockchain, and I said, blockchain works for very low volume stuff because it's a very compute intensive activity, but it works for things like real estate records and contracts and as well, things that you want immutability, you want transaction integrity for a long period of time, but low, and really it's because could you use blockchain for more things if you had more computing capability? And our CEO said, well, what about quantum computers? And that is one area that if you have quantum computing capabilities, some technologies that are now just infeasible become feasible. And back to that earlier point about AI, even AI runs into, when you start to get, and what we didn't say in this panel is, if you start to think about the number of sensors we now have on the grid today, and our plans, but I know other utilities have huge plans to put huge numbers of sensors on every wire, on every device, in every home, in every device, in every customer premise. Think about all that sending data. When we have vehicles and autonomous vehicles all sending data back, just ingesting, digesting, and whether you do it at the grid edge and you optimize it over time, you integrate all this data, you're going to need more computing power. I'm very optimistic about quantum computing coming and being able to solve that. That's the positive side. On the negative side, and I think you know this, once we get quantum computers at scale, you break all encryption that we have today. PKI is based on prime number factorization. Quantum computers can break that in matters of seconds, so we just have to develop a whole new security architecture.
If I could add to that, right, so for me, for example, we are one of the two companies that actually have a quantum running. So I think there's always a discussion about combining classical computing and quantum computing. They're fundamentally two different types of compute. Whenever as you mentioned quantum, it reminds me of in 2011 when we used to talk about AI. So it is at that stage where people are figuring out what the technology can do and cannot do. The biggest advantage of using quantum is around optimization. It's an amazing optimization engine because of the way the architecture works. So, and utilities because of network, there are some places where this network optimization can be used, but it's very, very early. Today, we are developing the assembly language for quantum right now, right?
Got one back here.
Hi, I was just wondering,
Do we need to wait for quantum computing to get to scale before we can start testing the integration of AI with quantum computing, and then, and it sounds like maybe even blockchain? Is anyone doing that, or do we need to wait for quantum computing to get to scale before we can start doing that kind of integration?
You can just go to IBM, search for IBM Q. We have open source the entire 50 qubit quantum computer we have. There's a way to test it, and you can actually develop your own algorithms. It's open sourced, and it's available for everybody.
Did you want to add something, Marissa?
No, I think with all technology evolution, it's never too early to start trying to integrate and test. It's just the place with which you do that, and then I think from a scalability standpoint, making sure that your data architecture and your compute architecture can expand and handle those new technologies in the future. I don't expect that quantum computing will play a large role in the distributed computation that we need for probably another 8 to 10 years. But now's the right time for us to start working on those technologies.
And if I could just add, I think AI can progress independently of,
Exactly.
I think there will be mergers in the future, but right now, AI is just in its infancy. It's really like a little baby AI, and it's like baby Yoda. It has to grow. You can tell I like Star Wars.
But still useful.
That's a good one.
So in our just last few seconds here, I wanted to give each one of you a chance to give some advice, give your wish list of what you would hope would happen in this industry to enable this capability of artificial intelligence. Marissa, you can go first if you want to, or Mahesh.
Yeah. Mahesh.
Okay. So for me, this is one thing I always leave whenever I have a discussion on AI. I always say AI is not magic, right? It's bound in mathematics and information theory. It needs a lot of data. So if you have to do AI, I say you have to climb what I call the AI ladder. So you have to have a method to collect data, organize data, analyze data. It's only at that point in time will you be able to infuse AI into any system. So this particular thing is what I call as information architecture. It's extremely important to AI. So I say there's no AI without IA. So please focus on information architecture. This is completely vendor agnostic. Do it with the vendor you choose, but this is extremely essential to succeed.
I think for small companies, the thing that we need is really strong partnerships with utilities. And so UtiliData and AEP have been strong partners for the last 7 years, and access in a very secure way to that system data has enabled us to build an entirely machine learning based product for grid operations. But that means that it's really hard for brand new startups to break into this industry without those partnerships. So my wish list is that utilities and startup companies partner early and allow for that exchange of data securely, but in a way to build new products.
And I will, those were great comments, and I just add, go beyond the technology and think about the culture of the organization, the change management that you need to do, because in many cases, you're taking humans out of the loop when you put AI into this loop, and how you're going to communicate that to the people affected and the organization at large.
Well, I want to thank the panelists for being here. I know everybody is extremely busy. These guys are extremely busy, and to take your time out to come here and share just 45 minutes of your knowledge is really, really appreciated. So.